are R red balls and Y yellow balls, drawn without replacement. So if drawing twice, probability both yellow is Y over R plus Y. After drawing one, total and yellow decrease by 1. Probability of first and second yellow multiplied gives 1/3, right? Since Y 0. Since we drew 1, total number decreases by 1, and of course, since we drew a yellow ball, the number of yellow balls decreases by 1 as well. So, the probability of drawing the first yellow and the probability of drawing the second yellow are multiplied together, which gives us 1/3, right? That's the equation we've organized, isn't it? So Y has to be greater than 0, right? So Y is the number of yellow balls, so it has to be greater than 0, right? Hey guys, this problem involves choosing plus or minus, and there's an R1 score here, you know? Check this out. You need to explain why it's plus or minus. Here's the R1 in this problem. Because the Y value is greater than 0, if this becomes minus, this value becomes negative, as it becomes greater than R plus 1. Even if we don't go into detail about it, since Y is greater than 0, we choose plus over minus. This is where the R1 score comes into play in this problem. So, we've covered that part. Now, what are we trying to find for C? Are we trying to find R and Y? What are the values of R and Y that make this equal to 1/3? But we found the relationship between the two up to this point, right? So what do we do next? Right? It has to be a positive integer, so that means the square root shouldn't exist, right? What are we supposed to base our findings on? We're using this as a reference point. Just to note, both R and Y are positive integers, right? But what we also need to do is substitute values for R, starting from 1. We just need to look for values that satisfy this condition. We need to solve this first, regardless of whether Y becomes an integer or not. We can't have a square root left over, right? So we'll substitute one by one to find it. For example, when R is 1, the square root becomes 4. So we add 2 and 4 and divide by 2, which gives us Y as, 3. I found one. This is how you find it. We just need to find 2 more, right, guys? We just need to find 1 more. What came next? I found the first one as 3, the second one, R is 5 divided by 2, is it? So this is how you substitute values to find it, guys. Is R 4? When R 4, Y is 6. Since it's 16, 349, it's 7. And since it's 7 plus 5 divided by 2, Y is 6, right? When R is 4, 6, that's it. Is that right, guys? How do we solve the next problem? Is it like this to find the probability of getting a yellow golf ball 3 times in a row? Right, like we did before. This time we were told there are 10 red balls and we designated the yellow balls as Y. So there's no such vibe as pi, but we created it for this problem. I represented it visually like this, showing that we drew yellow, yellow, yellow in a row. So what's next? So what's the next problem? A yellow ball has been added, then VSV plus 1. What did we find? By adding this one yellow ball, we calculated the probability of drawing 3 yellow balls, and it was double, so we create an equation to solve. So guys, this equation is... Did we do it the same way? By adding this one yellow ball, we found the probability of drawing 3 yellow balls to be double, this value, which means we need to create an equation, and solve it. Guys, this equation isn't it hard? If we simplify both sides and multiply, will it be solved quickly, right? Isn't it hard? So just this one problem.